So last time we were looking at how wires can produce magnetic fields, and this is actually a picture from our last video, and I just put it in here on purpose because when it's really kind of cool if you take wires and you curve them together, you can kind of see that inside of here the X's actually got really close together while the dots on the outside sort of got spread apart. And that's sort of the basis behind another idea that comes from using wires to make magnetic fields. Is if you take the wires and you bend the wires into different shapes, you can produce really strong magnetic fields. So for example, let's take a loop of some kind. So suppose we have a wire loop, something like this, and we have the current, and the current, we'll just do the same thing as this little picture up here. The current is doing this and something like this. The current's just going around the loop. If we would have something like this, just same way there's dots on the inside here, and you can use your right hand rule if you want. Inside of here, all these X's would be on the inside. There's dots on the outside for all of them, something like this. But those X's are really close together compared to the dots. And what will end up happening is inside this middle part here, you can actually get a very strong magnetic field by using loops of wire. So we use loops of wire in order to create very strong magnetic fields because it takes all those magnetic fields from the wire, and as you bend the wire, all these magnetic fields start overlapping. And you can get an incredibly strong magnetic field, especially if you start using multiple loops. Suppose you have one loop. Yeah, you're not going to have a strong magnetic field, but if you use the 10 loops or 50 loops or 10,000 loops of wire, you can get an insanely strong magnetic field by using these coils of wire. And this helps to create what are called electromagnets. Okay, so electromagnets are really strong magnetic structures that are used and created by using coils of wire to sort of magnify the magnetic fields by getting a whole bunch of magnetic fields to overlap around each other. So, and we'll get to that more in just a second. So it's really common to have coils of wire, and there's different types of setups out there. For example, there's different coils and there's different solenoids. Now, the only thing is when you use the right-hand rule for those, often it's done a little bit differently. You'll often see something like this. So here's, a coil of wire on the left with a whole bunch of magnetic field going through it, and then on the right you got some, got 5 loops of wire. Inside there's a piece of iron, so it can actually magnetize the iron, and the iron actually becomes an electromagnet, and it would be called an iron core electromagnet. And it actually makes a magnet out of the chunk of iron. Now, so for example, you could have a piece of iron or something like that. Here's our piece of iron, just like drawn the picture. You could have your coils of wire going around it, something like this, whatever it is. Just drawing a quick sketch here. And this will actually become a magnet. But what you can do then is you can actually take that piece of iron and make the iron longer, something like this, and that entire piece of iron will become a magnet. So instead of the north and south pole being stuck in here somewhere, this becomes the north and this becomes the south, and you can actually have a magnetic field going across here. So you can actually put other things inside of that magnetic field. You have a big wide open area, so you can actually make some really cool super large horseshoe shaped electromagnets, and then actually have stuff within them and actually apply the magnetic field to them. Okay, so that's kind of cool what you can actually do with them. There's lots of different things you can actually do with them. All right. Now, the thing is, when you do coils of wire and stuff like that, it's a little common to switch the right-hand rule. When we first did the right-hand rule, the current was the thumb and the fingers were the magnetic field because that's kind of what they look like. Well, when you do coils of wire, it's really common to flip the function of the fingers. So as you can see in this picture, the guy's grabbing the rod with the current going through it. The fingers actually look like coils of wire. So make your fingers the coils of wire showing the direction of the current, and then make your thumb the direction of the magnetic field. So in the picture here, the magnetic field would be going towards the right. It would come out the left end, loop around, and then go in the south pole on the other side. So when you're dealing with coils of wire stuff, and I'm just gonna erase this right here, get this out of the way for now. Get rid of that. So when you have loops of wire and stuff like that, flip the function of the fingers. I find it way easier to flip the function of the fingers. So suppose we had suppose we had some coils of wire here. Get a nice thick one here. Some coils of wire, something like this. I'm just going to redraw basically what's on the left side there, and the current is going up this way. Okay, so just like he has there, you take your right hand, almost just grab that thing with your thumb pointing to the left, and that's basically modified right hand rule. So when you get a coil or anything like this, it's often common to switch the two around. The magnetic field, this would be the north end, this would be the south end. The magnetic field, your thumb is pointing to the left, so the magnetic field would come out to the left and then loop around and go the opposite way, something like this. So if you're dealing with a coil or a loop, whatever you happen to be using, it's a really good idea to actually flip the actual function of your fingers in the right hand rule. It just works out better that way. Okay, and that's sort of how that works. All right. So that's basically what left hand picture shows. The same way for this picture up here. Okay, if you take your right hand and you point your thumb at the screen and point your thumb down the middle of the coil, your thumb represents the magnetic field going away from you, and your four fingers should be looping around the exact same way that the green arrows are pointing, which shows the actual direction of the current. Okay, so let's practice that just a little tiny bit here, and flipping the function of the fingers. Okay, so suppose I've got some coils of wire going around like this, do something similar as before, and the current is going around this way. There's my current. All right, so which way is the magnetic field going in the middle? Usually we care about the middle. Okay, so grab your right hand. Your fingers, your four fingers represent the loops of wire, and they sort of loop around. They up the side on the right, across the top and down their side, and your thumb should basically be pointing at yourself. Okay, and that's the way it would go. So the magnetic field's coming towards you. So you would draw the magnetic field in the middle, something like this. So there's the magnetic field coming out this way. Okay, suppose we had a loop of wires, something like this. This is actually called a solenoid. When you have a tube structure like this right here, that is what's called a solenoid. These are often called Helmholtz coils, with like a ring type structure, be like a Helmholtz coil, and something like this, like a tube structure, that's called a solenoid. For this one right here, let's say that the magnetic field is coming like this, and I want to know which way the current is going. Well, first of all, this is my north end, and that's my south end. All right, so for this one, I know the magnetic field is coming out the top and into the bottom. So inside, it would be, the magnetic field come this way. It would come through like this. So I'm going to point my thumb up. I'm going to point my right thumb straight up in the same direction as like that light blue arrow. And then my four fingers are sort of wrapping around towards the right. So my four fingers are wrapping around this way, and then around the back and then out their side. So my four fingers would be pointing towards the right and then looping around. So that's the direction that the current would be going in this solenoid. Okay, and that's sort of how you can modify and change the right-hand rule a little bit in order to do anything like a ring structure, tubes of wires, rings of wire. It just works a lot better. You can do it the first version as well, but most people switch the function of the fingers. Straight wire, thumb is the current, fingers the magnetic field. That's literally what they look like. If it's a tube or a ring or something like that, it works really well to flip the function of the fingers.